Today we'll continue discussion of this case to assess the earthquake effects. And last lecture we finished on the objects of the earthquake impacts, and we discussed them according to EMS and according to Ukrainian scale DS2, which looks like almost the same like EMS scale. We have same objects of the earthquake impacts, people, regular elements, structures and buildings, and also natural objects like avalanches, like landslides, rock falls, and like tsunami, etc. So those natural effects also helps us to find out which was the intensity of an earthquake. So next important question for us is to define what amount of what was the grade of intensity which took place in certain region. And to define that intensity, we can use both Ukrainian or European microseismic scale, and according to the effects which was felt by people, which was found in buildings and structure and other regular objects or natural objects, we can define what was the grade of intensity 6 or 7, and the rest of the scale also works like this. So, and we have to admit that there is a certain ratio between uh, magnitude and between intensity. And for example, same magnitude uh, can lead to various intensities on this dry land, on the surface. So like this, near the epicenter, we can find the intensity 10, and on this certain distance in 20 kilometers or more, we can find the intensity 7. And these slides shows us the situation better. So for example, if we have magnitude 8 or even 9, so in that case we will get all 12 intensities. For one certain magnitude, we will find all those intensities, because the epicenter will find uh, total destruction. We will find various effects on nature, right, like canyons creation or something like that. And on the difference, for example, to 200 kilometers, we'll find something rarely felt by various people. So that is why one earthquake have only one uh, intensity, only one magnitude, but it can get all 12 intensities. Depends on the distance from the source of an earthquake. So, and next, ratio in the form of table, which give us an ability to understand the ratio between intensity in EMS and same intensity in this two scale, and comparison of this scale with the magnitude. And for example, we can find that intensity 11 or 12 starts from the magnitude 7. So next important question that we have to understand, that we have to know, lies in next. So main goal of people to survive during the earthquake. So we have to find the ways how we can reduce the losses due to the earthquakes. So we have to find the ways to save people's life, and to reduce impacts on the economy of the states also. So, and today we'll start to consider this topic called seismic risks, risk classes of consequences, and seismic hazard. And first of all, we'll talk about seismic risk and reduction of losses due to earthquake. And I want to ask you, as for you, what are the ways to reduce the losses due to the earthquakes? Які шляхи зменшення постраждалих під час землетрусів? Чи є ідеї? Так, евакуації, так, підготовка шляхів евакуації, так, що ще? Так, ідеальний, так, перший є. Так, звичайно, коректні відповіді. Ще є, мабуть, якісь варіанти? А, так, ви вже, Василь, відповіли про наш шлях вирішення цієї проблеми. Так, звичайно, є декілька шляхів вирішення цієї проблеми. І першим шляхом вирішення цієї проблеми і це є найдешевший шлях. So, we know three main ways to reduce the losses due to the earthquakes. And first of those ways is to prepare the population to the earthquakes. And for example, in USA, they have six main steps to stay safe during the earthquakes. So first of all, you have to know what to do when the earthquake starts. Uh, Everybody heard that it is very important during the earthquake to run out from the building, and or if it isn't possible to find the load-bearing wall, find the opening and in that load-bearing wall, for example, door, and stay in that door opening during the whole earthquake. But I know that not that only some of our citizens know what walls in their buildings are load bearing. So, first of all, people have to know what to do due to the earthquake, during the earthquake, because not everybody know what to do during the fire. Yeah, but in every building we have fire evacuation ways, and I'm absolutely sure that not whole. Not all inhabitants of those buildings knows what are those ways to save their life during the fire, and the situation with the earthquakes is even worse, much worse, because nobody knows what walls in their buildings are load bearing, and nobody knows what to do when the earthquake starts. Where do they have to run? So first of all, to make a plan, to make that plan, you have to get certain information about your building. Next, secure your home. So if it is one-story individual or even two-story individual building, it is not difficult to make a certain preparation to secure your home. If it is multi-story building, it is a very expensive solution, and it is really a rare situation when some multi-story buildings had get that seismic resistance increasement because it is very expensive deal. I know one story about China, and in China, the director of the school get credit from state bank, and to that credit money he increased the seismicity of his school. And when earthquake took place, it was in 2 or 3 years after that reconstruction. All schools in that regions were destroyed, and only that school survived during the earthquake, because its director realized the consequences of the earthquake, and he decided to take a credit from a bank to make that seismic resistant enhancement of his school. So secure your home. But to secure the home, we know some additional waves ways. So we know that during the earthquake, ceiling scale can fall down. I'm talking about suspending ceilings like gypsum cardboard ceilings or other kind of ceilings. So it is important to in the interior finish to use earthquake solutions. Oh, by the way, even furniture can be hazardous to the human being during the earthquake inside of the building. Next step to stay safe during the earthquake, to um, get a kit. So we are people who living in the country with the war, not not each of us have a kit for the case of missile attack in their buildings. We know that it is better for us to have all documents and some expensive things to store in one place, so it will be easier for you to collect them in a minimum amount of time to save your life, and to have something with you when you have saved your life. And it is very important to make even for the case of an earthquake. Also, it is very important to know that during the earthquake you have to drop and cover and hold on during the earthquake. For example, if you have strong metal bath, so you can hide yourself in the bath during the earthquake. If you have a strong wooden table, you can hide yourself in that under that wooden table, etc. Such regular elements can also save the life during the earthquake. Also, after the earthquake, it is very important to check your house or your flat for the hazard. So you have to analyze: is it safe to return into your house, into your building, or it's not? And also it is very important to stay connected, so you have to find information about your neighbors, about your colleagues after the earthquake. So those six simple steps can save millions of lives due to the earthquake. For example, Japanese made one important step in addition to those simple steps. They have created a special machine with a showroom of a regular kitchen. It's a car, and it's a big car, and in that car they have uh, installed a container, and that container from inside, from interior, looks like the regular kitchen. And that machine has not only that container, but it has special devices which gives an ability to shake that container with the kitchen inside and with the people inside, and to model in that way the impact of an earthquake. And that container can take, I don't remember, 2 or even 4 people at the same time. And when people get there, they start using that machine they start to shake that container, and the people who are inside, they feel something like the real earthquake, and they try to behave, to calm down, to sit or to stand near stiff uh, and solid elements to adapt to an earthquake impact, and that helps people to save themselves from panic during the earthquakes. And there are some steps like this that helps to save life during the earthquake. And one more time, it is the most cheap. It is the cheapest way to reduce the losses during the earthquake. Uh, is everything clear, or one more time in Ukrainian? Так, найпростіший шлях для того, щоб рятувати життя людей, можливо, визначити як ці найпростіші 6 кроків для того, щоб залишитися у безпеці. Це є теоретичні дослідження і певні випробування. Перш за все, це мати план, тобто розуміти, що робити та куди бігти, коли розпочнеться землетрус. Перш за все, це вибігати на вулицю. Якщо це неможливо, знайти несучу стіну у своїй селі і у пройомі дверному у цій несучій стіні перестояти той землетрус. Тобто ми повинні розуміти та знати, де в нас є ті несучі стіни. Наступне це зробити будівлю, оселю небезпечною. І для цього можливо бути використані певні конструктивні заходи. Але якщо це багатоквартирна будівля, то це зробити майже неможливо. Є такий приклад, коли китайський директор школи узяв кредит та підвищив сейсмостійкість своєї школи, і коли стався землетрус, то усе навкруги зруйнувалося, а лише та школа пережила той землетрус. Це дуже дорого, але ми повинні розуміти, що не тільки підсилення будівлі є шляхом рятувати життя, але й цього може досягти, наприклад, зафіксувавши меблі, щоб вони вас не придавили під час землетрусу. Коли робите ремонт внутрішній, то підвісні стелі кріпити анкерами, що розраховані для сейсмічних районів, та використовувати спеціальні діхтунги та прокладки, які дозволяють декілька зменшити сейсмічний вплив, бо від обвалення стелі також можна отримати важкі поранення. Також мати набір усього необхідного для того, щоб вижити після землетрусу. Це якась така тривожна валіза. Там і гроші, і цінності, і документи, і те, що потрібно для того, щоб зігрітися, для того, щоб їсти певний час після землетрусу. Це також дуже важливий шлях. Наступний шлях це знайти такі надійні елементи, під якими ми можемо сховатися. Наприклад, дерев'яні столи чи металеві ванни. Вони також здатні рятувати життя. після землетрусу, перед тим як повертатися до будівлі, проаналізувати на наявність небезпечних елементів, обвалів, тріщин тощо. І безумовно, це залишатися на зв'язку, перевіряти своїх сусідів, своїх колег після землетрусу, як вони відчуваються, і також це може допомогти рятувати чиєсь життя. І додатково до цих кроків, наприклад, японці вони роблять додаткові машини з контейнерами, які моделюють в інтер'єрі кухню. Але цей контейнер він зафіксований за допомогою спеціальних приладів, які можуть хитати цей контейнер з людьми ну, всередині, і таким чином люди вчаться не панікувати та знаходити розсудок для того, щоб пережити землетрус. So next, second way to reduce the losses due to earthquakes is forecasting of an earthquakes. So forecasting is a very interesting way to save people's life. We know certain examples in the world history when scientists have forecasted the earthquakes. They have prognosed the earthquakes, and that situation saved people's life. For example, there was one earthquake in Haicheng in China in 1975, and during that earthquake, that big city. I know. I don't remember with the population near 1 million or 1 in the 6 million, like something like that. And almost the whole population was evacuated from Haicheng. And after that evacuation, there was an earthquake, and that earthquake was really hard. And according to the analysis of destructions of that earthquake, more than 300,000 people had to die during those earthquakes because of damages and destructions of buildings. So that forecast saved more than 300,000 lives, and that is a very interesting example. But in 1 year later, there were one earthquake in China, in Tanshan, which killed more than 240,000 people. And that showed us that that is almost impossible to prevent the earthquake. There are certain signs, there are certain marks that can show us that earthquake is possible, but it is absolutely impossible to predict the earthquake. So that is why it is good, but it is not a very developed method of reduction of people's life, of people or economic losses due to the earthquake. Is it clear? Do you have any question? Так, все щось додатково пояснити? Так, добре. So, and we are moving to our engineering way to save people's life and to reduce losses due to the earthquakes. It is earthquake resistant construction. It is very effective way, but it is the most expensive way, and it is our way because we don't know what to do with forecasting earthquakes. uh, we are trying to make something that we can to prepare people, but it is not only our individual work. It is it is necessary to develop a state program to prepare people to how to behave during the earthquake. But from today's point of view, we understand that it's impossible to teach our people how to save their life during the war effects. And I absolutely sure that for our people it's almost impossible to teach them how to behave during the earthquake, and that it is really important to be ready to an earthquake, because when war comes to people's houses, it shows us that they are not ready to those war effects. They are not prepared. They are not in shelters. They stays in their houses. So that leads to certain losses of people, because our people not ready to the war effects. So if our people not are not ready to the war effects, that is absolutely understandable that our people are not ready to the earthquake effects. So that is why it is really important for us to develop our engineering, our structural way to protect people's lives from the consequences of earthquakes. And we, as an engineers, as structural engineers, we have to work with a certain definition called seismic risk, and we have to have a deal with that risk. So, what is seismic risk? Seismic risk is a result of multiplying of two parameters. First is a seismic hazard, and the second is seismic vulnerability. In year 2002, in Odessa, was one conference about earthquakes, and one Japanese scientist said to our authorities, to our Odessa authorities on that time, that Odessa has seismic risk same as some regions in in Japan. So somebody funs about that. Somebody smiled about that. No, he, it's impossible compare Japan with Odessa. But he haven't thought about the Odessa seismic hazard and Japanese seismic hazard. He was talking about seismic risk. And here is what was the deal in that situation. First of all, seismic risk is the result of multiplication of seismic hazard and seismic vulnerability. And in Japan, they have really big seismic hazard. For example, in Odessa, we have much significantly less seismic hazard compared to Japan. But in Japan, they have the most part of their buildings are invulnerable. They are strong. They are designed to withstand the earthquakes. But when we are looking to our city, when we are looking to our Odessa building, we know that some of them uh, fall down without of any earthquake and without war effect. They fell down under their own weight. So there's a small seismic hazard, but big seismic vulnerability. In Japan, they have strong, biggest seismic hazard, but they have earthquake engineered building. So that is why the result of multiplication of seismic hazard on seismic vulnerability in Japan are almost equal, because seismic risk, it is not only about the earthquake hazard. Seismic risk is also about seismic vulnerability. Is that clear? Do you need any extra explanation? Так, сейсмічний ризик є результатом множення сейсмічної небезпеки на сейсмічну уразливість. І коли у 2002 році в Одесі на конференції сказали про те, що в Одесі певні регіони Одеської області, певні регіони мають аналогічний сейсмічний ризик порівняно з Японією. Хтось здивувався, хтось посміхнувся. Але ситуація полягає в наступному: що в Одесі є невеличка сейсмічна небезпека, але дуже вразливі будівлі. У нас багато будівель руйнуються під власною вагою, не кажучи вже про землетруси чи військові події. А в Японії навпаки, в них дуже велика сейсмічна небезпека, але в них будівлі є дуже сейсмічно стійкими. Саме тому в них низька уразливість під час землетрусів. Відповідно до цього, сейсмічний ризик там в них набагато менший. Тобто не набагато менше, він є таким же порівняно з Одещиною. І ми з вами розуміємо, що ось цим параметром ми нічого не можемо зробити. Бо якщо в Одесі є and we understand that that is impossible to make anything with this parameter, because if building market in Odessa still alive, if our real estate sells on the high with the high price, that shows us the importance of construction in this region. So that is why it is impossible to make something with seismic hazard, because nevertheless our seismic hazard developers will erect new buildings. And next parameter, which is absolutely under our control, is to reduce seismic vulnerability. And further, we will discuss first parameter: how can we define the seismic hazard of region, and how can we define the seismic hazard of certain construction site. And only after that we will discuss the ways of reduction of seismic vulnerability. So today we will discuss seismic hazard. We will discuss how to define the seismic hazard of certain construction site, and during the rest of our lectures we will discuss the ways how can we reduce seismic vulnerability with the calculation method, with the structural engineering methods, etc. So this is out of our control. This circle is under our control, and today we will start discussion of this topic. But as an example of the importance of that, what I said, I want to give an example of seismic risk in the poorest countries. For example, UNESCO shows us the next information that in countries with low income, less than $1,000 per person per year, on 1 million of population during the earthquakes, the number of deaths 7.7 times more than in countries with an average income from $1,000 till $12,000 per year, and on person per year. And for example, if you will compare the poorest countries with the richest, and richest countries with high income, more than $12,000 per year per person. In that case, in poorest countries, we will get 26 times more deaths compared with the high income countries. So that shows us that in poorest countries we will always get the biggest amount of deaths, of sanitary losses, because of the vulnerability of buildings which are erected there. Because in poorest country they don't have money to protect them from earthquakes. They have only little amount of money to save themselves from wind and sun. That is why they are using bad structural materials. They are trying to economy in every construction, and in every structural element that gives us the reduction of the amount of cement, and they are building poor cement concrete elements, which don't have necessary amount of load-bearing capacity. Also, they're using cheap reinforcement. In some cases, they're trying to put less reinforcement than it was shown in design. Прикладом того ж, як рівень доходів населення впливає на їх сейсмостійкість, демонструє нам ЮНЕСКО, і вони кажуть, що у країнах з низьким рівнем доходу у 7,7 разів більше буде загиблих порівняно з країнами з середнім рівнем доходу, і у 26 разів більше порівняно з багатою країною. І це пов'язано з тим, що у бідних країнах економлять на всьому для того, щоб захистити себе лише від вітру та сонячного впливу, від дощів, і саме тому такий підхід надає. Такий підхід робить будівлі сейсмічно вразливими, бо там економлять і на будівельних матеріалах, і на цементі в бетонних елементах, і на армуванні. Саме тому країни з низьким рівнем доходу вони є і сейсмічно більш уразливими порівняно з країнами з високим рівнем доходу на душу населення. So, next topic that we have to touch during our lecture is consequence classes. Do you know about consequence classes, and what is consequence classes? Класи наслідків. Класи наслідків. Так. Добре, тоді у декількох словах. In a few words, if you will compare Ukrainian and, for example, European approach to the consequence classes, in Ukraine you will find the more sophisticated way to define the consequence classes. In Europe, they have another approach. They only analyze the type of building, and according to them, that they define the level of consequence classes. In Ukraine, we have more sophisticated way to find out the consequence class, which is important for us for when we are trying to calculate load-bearing capacity of structural elements. And I want you to remember information about consequence classes, because it is very important for us to know the influence of consequence classes on seismic hazard on the construction site. For example, if we will start to erect on Didriksona a new building near our academy, if we will start to erect a new 30-floor residential or office building, it will get consequence class CC3. And if you will erect there a small buffet that sells some products, some food, it will get the consequent class CC1. And according to that, simple building will be calculated on the earthquake with intensity 7, and that 30 floor building will be calculated on the biggest intensity, for example, like 7.5, with intensity 7.5, or even more. And it is connected with the maps of of Ukraine's seismic hazard. What is the goal of that map? So first of all, when we are talking about definition of the intensity of the region, for example, what intensity in Lviv or in Chernovtsi or in Kharkiv, we have to know how to define that intensity. And to define it, we have to use our building codes, DBM, and according to the appendixes to the DBM, we have to find the seismic zones that those maps called ZSR, Ukrainian OSR 2004, and those maps are in the appendix B to our building codes. And here are those maps. It is map A, it is map B, and it is map C. If we will compare them, we will find that in Odessa, for example, on map A, we have intensity 7, and when we're talking about map C, we have intensity 8. Why is that so? It is connected. It is very connected with the probability of an earthquake, because when we are talking about map A, it takes into account the strongest earthquake once in 500 years. Once in 500 years. When we're talking about map C, it takes into account the strongest earthquake once in 5,000 years. Yeah, once in 5,000 years. So that is why this map C is used only for nuclear power station or something really hazardous, and map A uses for the regular buildings, consequent classes, CC1, CC3, but with the height less than 73.5 meters. If we have a residential or office building with a height more than 73.5 meters, in that case, we have to use map B. For some cities, for some regions, map B have biggest intensity of an earthquake compared to the map A. But for Odessa, when we're talking about Odessa, we have to know that in Odessa, according to map A and map B, we have same intensity. And also, we have such appendix to our code, which gives us an ability to define for each city, like, for example, Sokyriani. According to map A, we have in Sokyriani 6. According to B might be also 6. And according to map C, we have intensity 7. But what do we have to do when we are having to deal with certain foreign countries? For those cases, for example, when we are designing something in Europe or elsewhere, we have to use we have to use one moment. We have to use local building codes, but also we can use uh, software global or its online service, and I'll show you how can we use it in our practice. One second, I'll show you my another screen. And I'll show you global. And it don't work. I can show you another screen. Wait a minute. Oh, finally. Finally, and I'm showing you how it works. For example, we find work in where we can find, for example, in Germany. In that case, we are moving to a country and we are looking where is the Germany, and here is the Germany. Okay, and we are choosing seismic. Yeah, because according to that site, we can also check wind and snow impacts. And here is the map of intensity in German. For example, we find some job in Nuremberg. Okay, here is Nuremberg. Wait a minute, it want me to log into account one more time. Okay, I'm here. Wow, one more time. But now I'll choose Österreich codes. It's an norms in Austria. A norm, Austria, seismic, and for example, uh, sorry, I have some troubles. I don't know why. Don't want to let me go, let me in to that service because previously I was using it and it was good. So maybe it's internet problem. So the main idea of that okay of that side that you can find intensity and uh, ground acceleration for the certain location on the map. I'll try to record it in additional time and download it to YouTube for you to show how it works. And that's all for today. Do you have any questions? So, if you don't have any question, that's all for today. See you next week. And on the next week after our lecture, I think on next Friday, I'll give you tests for тест. Ну, тоді наступного четверга, то so next Thursday, during at the end of the lecture, I will give you 20 minutes to answer the quiz and uh, get your mark for the first model. So thank you, that's all for today. Тести будуть у Google формі. Ну, я добре, я тоді надам доступ до обох версій. So I will give you an access to both versions in Ukraine and also in English. So see you next week. Bye. Так, яке запитання?